MCQ 28 asks about the alloy of iron that is actually used for surgical instruments. So we have quite a lot of terms here: high carbon, low carbon, mild steel, as well as stainless steel. So I'll first tackle the first three, right? High carbon, low carbon, and mild steel. Now generally, if we take a look at element iron, we have our cation layers, and they are quite orderly. So if let's say there's actually a force that is applied towards my cation layers in iron, the cation layers can just naturally slide over one another. So this gives rise to a rather decent malleable feature that we can see in our iron itself. So when we go for high carbon, low carbon, and mild steel, they're just actually talking about the amount of carbon that's actually found inside steel. And steel itself is going to be iron plus carbon. So just a small setup over here with the same number of cations, you can see that the carbon actually disrupted the very orderly packing of my cation layers. And because of this, when a force is actually applied, the sliding ability of my cation layers is quite compromised, and because of this, I'll say that it gives rise to rigidity. So this gives rise to the strength. So as a surgical instrument, definitely we will want strength, right? We want to be able to cut through things without actually bending. So out of all A, B, and C, I will go with A because of the strength portion here. But some will then argue that a high rigidity does also give rise to a decrease in flexibility, or it gives rise to an increment in the brittleness nature of the surgical instrument. But one last thing to take note of is that with surgical instrument, we want to prevent contaminations of wound when we're actually touching any kind of organism. So we want to make sure that the steel we're using is actually rust-free. So this is where stainless steel is going to be the better answer here. So stainless steel has exactly the same feature of what a steel has. So just adopting the top portion of steel, we're going to have carbon that's found within. But what makes stainless steel stainless? That stainless portion here is actually a tribute towards its rust prevention characteristic, its inclusion of precious metals such as chromium. So at this atom layer, we can't really see much, but if I were to draw it out into a block, what will happen here is that the chromium is going to have a partial exposure towards the atmosphere. Right? Again, this is just a little bit of an abbreviation. You can see chromium that's actually sticking out here. So the chromium that's actually sticking out here will actually react with oxygen from the atmosphere. So the reaction of this actually causes us to create what we call as a chromium oxide layer. So this is a tough insoluble protective layer. Call this as a chromium layer. So as a tough insoluble protective layer, they actually cause the repelling of things like water and oxygen, which otherwise can actually be critical because we need that to be away so that it doesn't cause rusting of the underlying iron. So again, for surgical instrument, we tend to go for not just the rigidity, but also for the prevention of rusting. We want these equipments to be as sterile as possible. Stainless steel is the way to go here. So the option that we're looking for this is going to be option D.